I swear I know how to use computers. Okay, so welcome everyone. So we are here at React Miami, which is a front-end conference about a front-end framework. So I figured let's talk about back-end and infrastructure because I guarantee you no one else is probably going to be talking about that. To introduce myself real quick, my name is Dax. I actually live here in Miami, so I'm local, as you can tell from my outfit, probably. I live here with my wife, who's right there, who's here to support me, which is really nice. Everyone look at her, make her feel weird. I also live here with 2 cats and a dog. They're not here because they don't support me as much. So, like I said, I do know how to use computers, despite what you just saw. I am one of the creators of SST. So SST is a framework that helps people build applications on AWS. I know big bad AWS, the thing that nobody wants to use, the thing that everyone hates, but we try to make it easier for people to use it. There's basically like 3% of AWS you need. Like some of you that were here from Michael's talk, he kind of went over a lot of that. And they're actually fantastic services and they're great to build with. It's just hard to use them, and we totally understand that. So we build a framework that is focused on that 3% and building a fantastic experience with modern developer experience to the degree that we can push it. We try to make it as easy as possible for you to build on AWS. And specifically, we're very focused on serverless and how can we provide a really good developer experience for people that are building on AWS. So that's my background. That's what I work on day to day. It's a fully open source project. I get to work on open source full time, which is fantastic. And lately, we've been thinking about your front end. So SST historically has been mostly a backend framework. We focus on things like deploying APIs, cron jobs, queues, databases, all the stuff you need to power your backend and make it effectively infinite scale because we focus on the serverless side of things. And that's where we started. It's where we grew. It's where community is. But of course, there's your whole front end. And we had people come to us say hey, we love you using you guys for the backends. It's going great, but my front end is still deployed somewhere else. We have everything in our AWS account, but our front end is deployed elsewhere, which is a totally fine setup. I think a lot of you might use things like Vercel or Netlify or Amplify to deploy your front end and have them take care of all that for you. But there are some benefits to in this case, we can consider it self-hosting your front end. So we've been thinking a lot more about that and helping people deploy various front ends to their AWS account. So just call it out. What are some front-end frameworks you guys use? Just yell it out. No, go higher level, meta frameworks. The framework on top of the framework that is the thing. Remix, what is that? Just kidding. So we got Remix, what else? Gatsby, okay. What else? Are you the same guy from yesterday that was yelling Angular for everything? So I'll finish it for you. So we got obviously Next.js. We've got things like Solid Start, which is newer. SvelteKit. We got SvelteKit. We got Astro. We got all these new things coming up. And the key with a lot of these new frameworks is, I think for the last 5 to 10 years, we've been building our sites statically and deploying them statically, which is very simple. But a lot of these new sites or new frameworks are all about server-side rendering. So we're bringing back the backend. We're bringing back the ability to run code per request. And that enables a whole lot of features. And these new frameworks are taking advantage of that and making it easy for you to render your front end from the backend and do everything you need to do there. But as a side effect, they've gotten a lot more complicated to deploy than just building your stuff statically as an SPA and then deploying it to a static file server. So it's gotten very complicated. And like I said, a lot of you are using things like Vercel, Netlify, Amplify, so whole suite of companies making it very, very easy for you to use these things. And I wanted to dig into, it's great to use these things and they hide a lot of complexity for you, but just for fun, let's go look to see what they actually do. So that's what my talk is going to be about. The amount of work it takes to actually deploy what feels like a very simple front end to a provider like AWS. So this is hardcore engineering. This is serious stuff that these people are doing. And I really wanted to capture the effort behind these things. And I found the perfect metaphor. There is something called the Airlander 10. The Airlander 10 is the world's largest airship. And it takes a crazy amount of engineering effort to get this thing literally off the ground. But when you see it, it's just this like, big thing that just floats, and like you don't really think much of it. But it took like a crazy amount of effort to really get there. So here's a picture of it. I don't know why you guys are laughing. This is crazy engineering effort right here. And as we can all tell, this picture screams one thing, right? It takes a whole lot of back end to deploy a front end. I still don't know why you guys are laughing. So that's what we're gonna get into. So this talk is gonna be about Next.js. Sorry, Kent. I would have made it about Remix, but a bunch of Vercel employees showed up at my house and started threatening me, so I had to switch it and make it about Remix. I mean, how do you guys think they hired all those great engineers from the React team? They threatened their families. But no, more seriously, the reason I'm going to do it on Next.js, I actually have never used Next.js. I'm giving you a whole talk about Next.js. I've actually never used it. But the reason I'm going to be talking about Next.js is, weirdly, so we do support Remix, and Remix is actually extremely simple to deploy to these. Ken's nodding. There you go. I got your back. Extremely simple to deploy on all kinds of providers, and because I think they followed a model where like they actively made that a thing that they cared about. So if I did this talk about Remix, it would be like 5 minutes. So I picked Next.js because it's a lot more complicated and it's a lot more interesting to like dig into the deployment side of it. And I'm not saying it's complicated for no reason. It's because there's a lot of great features in there that are hard to replicate outside of Vercel. Let me see. Oh, just a disclaimer, because you're all a bunch of nerds in this room. This is going to be a little bit of an idealized description of how to deploy. Infrastructure is already boring. I don't want to get into details like, well, technically, AWS can only give you 20 behaviors per CDN, and like, there's going to be some things that seem inaccurate, but I'm like kind of smoothing it over so the talk is, digestible. Do not tweet at me being like, well, technically, you were wrong about this. I know. Yeah, exactly. Don't give me the actually. So disclaimer, it's more about the concept, less about the literal exact details. So how do you actually go about building and deploying Next.js manually? So the first step is called something called standalone mode. So Next.js does make it, they do provide some help to get you deploying in other places. They have something called building in standalone mode. What this does is it just ships a version of Next.js in a very raw format. It's like the output of it is in a very raw format, and you can kind of take that and start to deploy it in different ways to get it all working. There's also a secret trick in there called minimal mode, which lets you do a few other things, and I'll get into that in a little bit. So when you build it in minimal mode, you get all of this stuff. And this is just I did a create next app, and I ran a build in standalone mode, and you get all this stuff. So you look at this, and you're like, okay, I'm not like, who wants to deal with this? Nobody really wants to deal with this. So it is a lot, but in this talk, we're going to go through each part of it. It does seem really complicated. By the end of the talk, you guys are still going to think it's complicated, but maybe it'll be interesting to understand how it all works. So let's deal with the simplest things first. So static files, like what exactly are static files? These are things that do not change per request. So you can think about things like images. It doesn't matter who's requesting it, when they're requesting it. Certain images are just going to be static. Things like your CSS might be totally static. Your JavaScript might be totally static. You might have fully rendered pages that are totally static because it might be like a landing page on your marketing site. There are things that just do not change. So what's great about these frameworks is you can opt into the parts that are dynamic, right? You can say like, okay, like these pages are very static, so just serve them statically. These pages, need to talk to the database. They do other more complex things. And when you run the build, Next.js will kind of split it out in that way. How do we deploy static files? So specifically on AWS, we use something called a service called S3. Yeah, S3. I'm sure you guys have heard of S3 before. So S3 is one of AWS's oldest services. It was the beginning of them terribly naming everything. So I think S3 stands for Simple Storage Service, something like that. And they abbreviate to S3, but they're also like, no, it's an S3 bucket. And now like we talk in terms of buckets, which is like, I don't know what a bucket of files is, but I guess that's what they went with. So S3 is basically an infinite file storage service. It can store as much data you need. It can serve it to as many people as you need. It's extremely cheap. It is one of the cheapest ways to serve static files. And then there are things that are cheaper, but for what you get, it is fairly cheap. It can handle serving files at any scale. But the issue with S3 is when you create an S3 bucket to put your files in there, it only is in one region. So if you deploy to Virginia, which is where half the world deploys to, we're all on the East Coast right now. You fetch a file from the S3 bucket. It's probably going to be pretty fast. People around the world, it's going to be kind of slow for them to fetch all the way across the world to the S3 bucket. So that's not enough. So you also need to put in front of it, it's called a CDN. And I'm sure a lot of you are familiar with this. A CDN is a content delivery network. So S3 buckets are located in AWS's main regions, and they don't have a ton of main regions because they're big, like huge data centers with multiple availability zones that are very expensive, and they have the most extreme architecture and performance and servers in there. But they also have these other locations, these CloudFront locations, which are a lot smaller, but like distributed way closer to users. So if they have like 4 or 5 main regions in the country, they might have like hundreds of CloudFront locations across the country. So these locations are smaller, but they're nearer to the user. So CloudFront will sit in front of your S3 bucket. So when someone comes to request a file, they're going through CloudFront first. So they might connect. So if we're all here in Miami, we might connect to a CloudFront location nearby. I don't know where it is, but I know they do have some locations in Miami. We might connect there very quickly. And CloudFront will say, okay, what file are you looking for? You're looking for this image, maybe the image that we showed earlier of that airship. Does that location have it? No, it doesn't have it. Then it's going to go fetch from the S3 bucket. So that first initial request ever from someone requesting that file from this location will probably be slow. But from then on, CloudFront will cache it. They'll keep it around here in case other people in Miami also need to request it. So that's how you provide good latency across the world. These locations kind of lazy load all these static files over time. And of course, they evict them. If there's like not a lot of people here that are accessing it, they might evict it and they might refetch. But for the most part, building something that gets a decent amount of traffic, you put CloudFront in front, you're going to see some pretty good latency benefits there. So it effectively acts as a cache. It also handles things like custom domains, like if you want to route, mysite.com to the CloudFront to your site, you route it to your CloudFront distribution, and AWS will make sure that people get routed to the nearest location for them. And at this point, you could be done with deploying your Next.js app if it's all static, right? If every single page of your Next.js app is 100% static, you can be done here. That's kind of what's great about a lot of these new frameworks. They support every mode. This is a fully static mode. They might support, slightly dynamic, like highly dynamic. You can kind of choose how far you want to go with all of this. So I think for most of us, for the past 10 or so years, we've been deploying kind of like this, and we kind of stopped here. And that's pretty easy. So next question is, what about dynamic routes? So if you look at the files that are here, you do see some JavaScript files, right? You see like pages, API, hello. So these are routes that are dynamic. So Next.js lets you create API routes, which is, they're not really meant to serve front ends. They're meant to serve things like JSON requests. Just you can kind of mix in API endpoints as you need, which are clearly dynamic, right? An API route is probably going to need to talk to your database. It's probably going to need to do some additional work. You can't statically compute this. So this needs to be deployed somewhere completely different. So these dynamic routes get deployed to a Lambda function. So are you guys familiar with Lambda functions? I'm sure. Yeah. Yes. Okay, cool. A lot of excitement for Lambda functions. So what is a Lambda function? So this is something that AWS came out in, I don't remember the year. I'm going to make it up, 2014, let's say. Like I said, this talk is not going to be accurate. It's more about the vibe over the accuracy. So Lambda functions are a really innovative concept, and they're a very interesting way to do compute in the cloud. So instead of, historically, it was rent a server. And when you're renting a server, what you're saying is, I am pre-buying capacity that's going to be running all day. It's going to be running 24/7. I'm going to need it every month. And I think when I started getting into the cloud and all this stuff, you paid per month pretty much for the server. Then at some point, AWS was like, okay, you don't have to pay per month because we know that you might only need it 8 hours of the day. So you don't need to pay for the whole month. You can pay for the server by hour. So you might want to run the server up during the day and like shut it down at night, or like have fewer at night. But they kept going with this and saying, okay, now you can pay by the 100 milliseconds, right? And that's when Lambda functions first came out. They were saying, okay, you don't have to run up anything at all. Just give us a code. Whenever it needs to be executed, we'll spin something up, run the code, we'll bill you per 100 milliseconds, and we'll shut it down. So that gives you crazy granularity on how much compute time you're actually using. And these numbers end up being very counterintuitive. I think a lot of people think like, oh, that's probably like 20 or 30% cheaper. I consulted with a company where they're like a full real stateful deployment. They were spending around $3,000 a month for. For real workloads, you need to make sure it's highly available, all kinds of things. We moved it to Lambda functions and it dropped down to $50 a month. So from $3,000 to $50, like it is kind of crazy when you use this stuff correctly. It can get really cheap, especially at scale. And another interesting fact is I said 100 milliseconds. That's what it was when it first came out. So if your function ran for, let's say 20 milliseconds, it got rounded up to 100 milliseconds, which is fine because it was still cheap. And then at some point in the last couple of years, AWS said, hey, you know what? We can now bill you per 1 millisecond. So overnight, if that function was running at 20 milliseconds, your bill just dropped 80% overnight. And so what's kind of cool about using some of these platforms, people are afraid of things like vendor lock-in, and that's definitely a thing. But with the modern set of cloud companies, they've kind of learned from the previous set of companies that like really focus on lock-in and trapping their users and how that doesn't work long-term. AWS definitely understands that they need to be driving costs down infinitely, because the moment they stop doing that, people are going to hate them and want to leave somewhere else. People already hate AWS enough; they don't want to hate them for the pricing side of things. So Lambda function is one of the best ways to say I need to run some work. Here it is, and run it. And not everything can be modeled in a Lambda function. I think a lot can. I think people underestimate how much can be built this way. Like I built some really crazy full applications purely on Lambda functions. But people kind of see them as maybe they're kind of like toys. But you can do a lot with them. So we take the dynamic parts and we deploy them each as a Lambda function. So each route, like your hello route, maybe like a front end route that like renders something from the database, each one of those gets deployed as a Lambda function. The CloudFront CDN will check, okay, what path is this request for? And then it'll send the request to the appropriate Lambda function that handles that. So just quick aside here, why not just one big function? Why make a separate function for each route? The one thing to consider with Lambda functions are cold starts. Cold starts are not well understood. Not every request creates a cold start, and what a cold start is you give them the code, they need to like boot up something to actually execute the code. I think there's some misconceptions that every single request causes a cold start. It's not exactly how it works. The first time you deploy your app, nothing is running. When a request comes in, it will cold start to boot something up, but then they keep it around. They kind of keep it warm for a little while to serve any additional requests. So over time, you'll have like a pool of warmed functions. But cold starts are a real issue. When you split stuff into separate functions, that lets there be fewer dependencies per function. Hypothetically, you might have like one really fat, chunky dependency in one function that's not used by the rest. So if you put it all in one big function, it kind of gets put into one bundle, and that kind of creates worse cold starts. So we try to split it up into separate functions so that you'll get more cold starts, but they'll be faster. It is like kind of a tricky trade-off. So the next thing here is NFT files. And this is the only time in the history of Miami that someone's going to say NFT and it's not going to be a scam. So what are NFTs? So NFT files are, they kind of show up alongside, you see like in like the JavaScript files that we deploy for the server functions. This is a cool thing that I think Vercel actually created this library. And there's a few different ways to do this and a few different tools to do this, but NFT basically takes the function that you want to run, the code you want to run, and traces all the dependencies and says like, okay, they're using this dependency and that dependency is using these files and those files are using these other files. And it creates a tree of all the dependent files. So you can't just deploy this hello.js to AWS Lambda, you also have to include all its dependencies. So we will trace these NFT files, find all dependent files, bundle them up into one single thing, and then deploy to AWS. So it's great that those files are there. It helps us do that. Keep track of what dependencies everything needs. So what about middleware? So middleware is a new feature in Next.js 13. They're basically little plugins that you can add to your Next.js application. They can intercept requests, modify them, return the responses. So they're like not meant for like heavy logic, but for simple things like oh, I want to like, add an internationalization header. I want to like, do a little bit of auth, like kind of basic things like that. So we need to deploy the middleware. So we deploy the middleware to Lambda at Edge. So originally, AWS released just AWS Lambda functions. Over time, they released Lambda at Edge, which are basically just the same Lambda functions, but running in those like hyper-geographic CloudFront locations. So the reason we run middleware there is because they intercept the request. Sometimes they can just short circuit it and like respond right away. So let's say someone's trying to access a page that requires authorization. The middleware function at Edge can decide, okay, this person isn't even sending me an auth header. They're not allowed. Like, why even let the request make it all the way to the regional location? Let's just give them like a 401 right away. So middleware is great to run at Edge because it can kind of intercept some of these things early. You kind of get better performance. It can also modify the request and add additional details before it goes to the Lambda function in the region. So you can do things like look up the client's geography, like different things, whatever you want to do. And you can deploy that at Edge. We also support running everything at Edge. So you can also say like, don't even put the Lambda functions in the region, like just push them straight to the Edge. So everything is running at Edge. There are a lot of benefits of doing that. Most architectures aren't really set up to do that well today. So we don't see a lot of people taking advantage of that. But it is a very cool setup. You just need to be, the reason it's tricky is if you move your Lambda functions closer to your user, they're getting further away from your database. So a lot of like things that you assume will be fast start to become slow, and you might actually get worse performance when you push Lambda functions to the edge. So I generally don't think everything's gonna go to the edge, but if you do build a very sophisticated architecture where you still have like a regional API and your Lambda and your Next.js app never talks directly to your database, they send like single requests to your regional location, then it can make sense to use kind of push everything to the edge. But you have to very specifically architect for it. The next thing is ISR. So what is ISR real quick? I'm running out of time. ISR is complicated. It's a feature in Next.js that lets you cache pages that you've rendered already, and then serve a stale page, but say, okay, if we've been serving the stale page for too long, let's like recompute it asynchronously. So the next person that shows up gets a new version of it. So it's a little bit complicated for now. Basically, a request will come in to basically they'll hit the middleware, and the person will always get an instant response. So whatever the last known version of this page is, we're going to serve them right away because we have that saved in the cache. But we're going to say, okay, we served them this page, but we haven't regenerated it in a day. So let's put it into a queue. SQS is another AWS service. It's effectively just a queue. You can put stuff in there. It can reliably trigger other Lambdas. If the Lambdas fail, it'll still re-trigger because it's stored in the queue. And you can kind of do very powerful because you can make sure stuff never fails. You can scale things out massively in parallel. It's a great fit here. So we'll put those requests to say, hey, we want to, okay, we serve this old page to them, but in the background, we're going to send it a request to regenerate a Lambda. That's going to regenerate the page and then save it in the S3 bucket, so the next person that gets it still gets a new version of the page. And that's very useful for things that like you want people to have the latest version, but you don't like absolutely care about them having the latest version all the time. So you might say, okay, it gets stale after an hour, so at most recompute it per hour. But like outside of that, I don't really care about them having the newest thing. And again, what's great about these frameworks is a level of control to say exactly the trade-off between performance and the amount you're willing to pay for computing things. The reason I said complicated for now is there's a new feature coming to CloudFront called SWR, stale while revalidate. These are a standard, so ISR, incremental static regeneration, was a kind of Next.js Vercel creation. SWR is basically like an open standard that effectively does that, and CloudFront will be supporting that soon, so ISR will kind of go away. It's kind of an artifact of the way things are currently done. So one last thing, because I know this is getting boring, image optimization. So another great feature about Next.js is it does a bunch of image optimization stuff for you. So there are special routes in Next.js. I think it's like underscore images. Something. Again, I'm not a Next.js user. I don't know what I'm talking about. There's an underscore images route where it'll do image resizing. So instead of directly serving images of a certain size, it can kind of compute depending on the screen, depending on whatever it needs. Here's the size of image I need, and it'll make a request to this special path. So we deploy yet another Lambda Edge function, because again, this is the type of thing that can be done at Edge. It doesn't need to really talk to a database or anything, where that'll try to figure out, okay, have I pre-computed an image of this size already? If no, let me fetch that image from the S3 bucket, resize it, and then save it in the cache with sort of appropriate cache headers, so this doesn't have to be recomputed all the time. So what we do here, it's kind of interesting. Lambda also supports ARM, so there's a flavor of Lambda that runs on ARM CPUs. These are a lot faster, these are a lot cheaper, and they're a lot more efficient. So for doing things like image resizing, we pre-compile a library called Sharp for ARM. Sharp is a native image resizing library that has JavaScript bindings for it. It just resizes images very fast and very effectively. So we do that and we deploy that to Lambda at Edge. And that is roughly it. So again, a little bit idealized. There's a lot more chaos here than what's already the chaos that you're seeing on the screen. But this is pretty much it. So your Next.js app, which feels like a single simple thing, is actually this amalgamation of like all these different services working together. And this is just one opinion on how you can deploy Next.js, right? This is our flavor of deploying on AWS. Every single piece here, you could have made different decisions. So we try to figure out, okay, for 95% of people, what is the best setup for them? And this typically works. And of course, none of you want to do this yourself. Don't do this yourself. It's dumb. There's no point doing it yourself. I got to show my product a little bit here. So this is very complicated, but ST can do it for you. This is 4 lines of code in TypeScript. So the way we work is everything we build, you can spin up all the infrastructure you need just by defining it in TypeScript, and we will deploy it into your AWS account. So 4 lines here, new Next.js site, add the path to your Next.js app, add a custom domain. We'll do SSL certificates, everything, and just get this all deployed. Again, most of you probably don't need this to deploy to your AWS account, but if you're working at bigger companies that are at a scale where some of these other providers are too expensive, or you just need everything in one place for compliance or organizational reasons, that's why you might do that. So yeah, go check it out. I appreciate it. And that is all I have. Follow me on Twitter. 9 out of 10 tweets are not useful, but 1 out of 10 tweets are very useful, just like this talk. So yeah, follow me, and thank you, everyone.